Hello guys, today I'm going to give you a demo about several different RPC solutions. My name is Wei Zhang, and if you have any questions, please leave your comments down below. And let's start with a demo of socket programming. So why socket programming? Because we're talking about RPC, right? And why socket programming? So socket programming is very basic for the client and server-based program. And if we want to communicate between a client process and also a server process, you need to deal with socket. Let's say, if we go back to the very basic. And actually, socket programming is also the cornerstone of RPC. So we need to understand what's going on behind the scenes. So first of all, at the server side, you need to create a socket. After creating the socket, you need to configure the socket. And then you are going to bind the socket to the network layer address and the port, for example, the IP address and also the port number. And by doing this, you are basically exposing the socket, and you are going to listen for any connection creation request coming from the client. So at the client side, what you need to do is to create a socket. After that, you are going to try to create connection with the server socket. And once the connection creation request is sent to the server can accept this request, and then the connection will be established. And after that, the client can send any kind of a data or message to the server, and also the server can reply back any kind of data or message through the connection that we just established. All right, so let's go ahead and see how we can see an example that how we can implement this. So here at the repo, actually, we've already prepared a series of demo projects for you guys to understand different RPC solutions. And we also include a socket programming example right here for you guys to understand. So basically, for the server-side program, as you can see here, we basically create the socket with this function, and then after that, we do some preparation for the socket, including, let's say, we indicate the network address, the port number, and then we bind the socket to the address and also the port, and then we listen for any connection creation request coming from the client. And this function is totally a blocking function that will block the program, server-side program, to run until it receives any request. After receiving the request, it will just go ahead and then accept this connection creation request, and also after that, it'll just read whatever, try to read whatever that is being sent from the client. And then after receiving a message, it'll just write some message back to the socket. It's like sending back a reply to the client. And then for the client side, also it is very simple. So first you create this socket, and then the second step is to basically create this connection. And after that, you are basically writing or sending the data to the server and waiting for the reply. So that is what's going on for this socket programming project. And we build up this makefile for you guys to quickly compile the program, and also you can quickly run the server program, also the client-side program. And then later on, you can just view the result by executing this target. Okay, so now let's see. So you basically generate the server and also the client. So how do you basically run the server? Let's see. For example, first of all, let's say if your server runs at this port number, now basically this server-side program is listen at this port number, and the IP address should be the IP address of this host. So what you can do here for the client-side program is like you can basically run it, and since both client-side program and also our server-side program are running at the same machine, so basically you can use the local IP address. And the port number is what you just specified right here. So 65432. All right. So now I just enter the message like this, and so as you can see, basically the server-side program got the message that you specified and sent from the client, and then it replies the message, okay, I got your message. So the client received the message and printed it out. So that's basically what happens for the socket programming demo. So as you can see, so basically the message that you are sending between client and server is arbitrary, and the message processing is also arbitrary. You can do some type of message processing against the message that's received at the server side, but the thing is you have to write repetitive code for the network I/O again and again for each network communication. This is the most time-consuming part, and this is really tricky and trivial. This is a general picture of the RPC. As you can see here, we basically have the IDL, the interface definition language. So for this one, you basically define your interface with this kind of language, and you basically generate the IDL source and then put it into the IDL compiler. So the IDL compiler will generate the client stub and server stub for you, which are all language specific. And also for the IDL compiler, it also will generate some interface headers for, let's say, the client side program, also the server side program to invoke. And for this one, actually the IDL defines the procedure that will be exposed as an interface, and also the network I/O is hidden to application layer, encapsulated by the client stub and also the server stub. And the communication will be handled by the operating system. So in this way, you don't have to repetitively write a lot of code on like how client and server do the network I/O. So you can just basically focus on what is the message that you are going to send, and also like how to process the message, or what behaviors will be conducted at the server side once the message is received, and also what behavior should be executed when the client receives the reply. Let's go for an example of the Sun RPC solution. So what is going on? Basically, the first step at the client process that the client call a procedure that has been exposed as an interface. And then the client stub will just marshalling this invocation into a message where we have several different items in this message, like the name of the procedure, and also the parameters that will be passed into this function. And later on, the message will be sent across the network. So this one will be handled by the stub. The stub will put this message to, let's say, the network layer of this operating system, and the operating system will send out this message to the server-side operating system. Once the server-side operating system receives this message, they'll just hand over the message to the server stub, and the server stub is doing the unmarshalling, which is to unpack the message back to what it was at the client side, give it a name of the procedure and also the parameters that we passed into this procedure, so that the client stub knows which function to call at the server side. So as you can see here, we only have this XDR IDL source for you. So it is written in a language that is called XDR, extension data representation, whatever. And you can, on our project page, we also provide a instruction on how you can execute this program. And you can also know something by looking at the references that we give. And you can know a little bit about like what is the XDR, what is TI, RPC, the entire architecture of this ONC Plus technology. But here I'm just only going to show you how you basically can run this program. So with the RPC gen command, you can basically generate a series of files that is actually the client stub and also the server stub, right? And also you have this header file for the interface. So this is the header file that's been generated. And as you can see here, so they basically have already generated different kind of functions. This is the client stub. So the client stub deals with the marshalling of the message. And also, if you go for the server stub, actually you will find a skeleton code for the server-side program, and also like how the server-side program works for unmarshalling and dealing with the message that's been received from the client. And okay, so after having this, now we're going to generate some template code for the client side, and also a template code for the server side. And let's edit both client and server side code. So for the client side code, what we can do, basically remove all of this function, and we copy with what we have already provided. And also we can modify the server side code. So for this one, actually, as you can see, we also provide some implementation against the server-side program. And if you guys are interested, you can always take a look to see what's the difference between the implementation that we provided and also the code that has been originally generated. And after that, we're going to compile both the client-side program as well as the server-side program. And once we're done, we can basically run the server. For example, if here we come back to this one, and then now we're running the server program. And now let's see if we basically run this client-side program locally at the same server, what will happen. So message received, and as you can see, we basically record everything that the server program generates into this log file. So what we can do is to see what is going on right here. So every time when we run this client, it'll just print, okay, this server process the request. The time when the message is received will be printed. So this is a very simple example of the Sun RPC. Let's basically do a analysis against the RPC and what's going on behind scenes. So basically, as you can see for this OSI 7-layer model, we have, let's say, physical data link, network transport session, presentation, and also application. And actually, the IDL, which is the XDR that we just wrote, is basically the IDL, and it appears at the presentation layer. And also the actual RPC communication happens at the application layer. And the client stub actually encapsulate, or let's say the client stub and server stub, including some of the network communication components in the operating system, covers all other works down below, all the way down to, let's say, session, transport, network, data link, and physical. So this is what's going on. Okay, so now next I'm also going to introduce another RPC solution that is called Java Cobra. So this is also a very old technology, and Cobra stands for Common Object Request Brokerage Architecture. And this is developed by Sun Microsystem, and now it's already a Oracle thing. And ORB here stands for the Object Request Broker. And as you can see, the client program and also the server-side program also works on top of the Object Request Broker. And the ORB here actually handles the, let's say, marshalling and unmarshalling, and also the network communication. And the internet inter-ORB protocol will just handle like the actual transportation and also the protocol that will be transferred through the internet. Also, we'll provide a document if you want to know more details about this technology. But here, we're going to just demonstrate how this one works. So in our tutorial, we actually provide a instruction on how you can run this program. So as you can see here, if you go back to, let's say, the Cobra example, and here, this is the Hello World example. So if you click right here, you will find this example. And all you can do is follow the tutorial to run this program. But here I'm just going to show you how you can basically run this program. And the first thing you need to do is to run this program so that it'll just generate a folder where it includes a lot of different Java source files. That is actually the some of the stub code, and also like the server-side bindings. And as you can just basically see through this tutorial to know which file, the functionality of each file. And also later on, what we're going to do is to compile everything, every Java file right here, so that it'll just generate some Java class file. So the compilation is done right now, and the next step is to start this ORB binding process. That is basically a daemon process, and you can see if I just start it right here, and if you run this command ORBD, okay, so you can see this ORBD program is running. Now we start the server-side program. So since we start our ORB at this port number 1050, so now we start this server-side program, indicating the ORB port number and also the host to be localhost. So the server-side program is running, and now we're going to run this client-side program. And as you can see, Well, definitely, the server-side program receives some certain message, but a exception has been thrown, and seems like we have no clue what is going on. But if you go to, let's say, the actual code, it's going to be a very interesting thing. So actually, I have written this client-side program just for you guys to explore what is going on, and also what's the why this ORB is so important. So basically, I set up several different questions for you guys, and you can test through different cases. You can alternate, let's say, shutdown and also destroy to see what's the difference behind this, and also you can try question 2 and also question 3. And if you can answer all of these questions, I believe you will figure out, okay, what is going on for this exception. Basically, I'm done with this example, but once you finish this example, what you need to do is to kill this ORBD. So first, you know what is the process ID, and then you do, yeah, basically you just kill this RPD. Otherwise, other people cannot run this program again, or this port number will always be occupied. So this is not a good thing. So previously, we have learned how to implement RPC communication using Sun RPC and also Java Cobra. But both of the solutions are very language specific. One is particularly you have to write C program, another one is like you have to write Java program. But what if you want to implement the RPC communication between different process that is written by different kind of programming languages? And here's the solution, that is the Apache Thrift RPC. So this one is first published by Facebook, and now it's already managed by the Apache Software Foundation. Well, as you can see, this is basically the architecture of Thrift. And as you can see here, the interface and that will be exposed is generated as this server processor, and also the client-side skeleton program will be also generated. But underneath, there's the T protocol and T transport that can be altered for several different implementations. For example, the T protocol, actually, you have a lot of choices for the binary protocol, the compactor protocol, dense protocol, and also JSON protocol, and many other different kind of protocols, so that you can basically marshalling and unmarshalling through different kind of data formats using these protocols. And also for the transport layer, you can implement with the socket programming, and also some other alternatives like the frame transport, file transport, memory transport, and also zlib transport. And since all of these implementations are following the same standard, same specification, and actually allows you to have the interoperability between different languages, because the T protocol and the T transport can be implemented by different programming languages, and different implementation follows the same specification, so that you can basically implement this RPC communication with different kind of programming languages at the client side or the server side. For example, if you have a server-side program written in Python, you can basically call whatever you have exposed using a client-side program that is written in C or maybe Java. This is the Thrift RPC project, demo project. And in this project, as you can see here, we also define this thrift IDL. So it is still a very specific IDL standard that you need to learn. And also, we provide a server-side program written in Python. And also we provide, let's say, the C++ client and also the Java version client. And unfortunately, well, currently, since our diskette cluster has been changed, has been reinstalled, and currently we do not provide the support at the computing node for thrift. So you can only test thrift on the head node. Alright, let's see how we can run this program. So as you can see, this is the thrift RPC folder, and here, as you can see, this is the thrift IDL. So this is the content where we define this function and also the returning data type. And first, let's build up, let's say, the C++ version of the client. And as you can see, this is the makefile. And then the thing that we compile is like, first we generate this C++ stub code, and by doing, let's say, thrift gen cpp. And similarly, we can have this. So that is the hello thrift. Okay, so this one will allow us to have some Python code right here. This is the Python version stub. And now, so let's suppose you are going to run this Python version server. This is the server, and also you are going to run this client. This is the C version client. As you can see, they actually interact with each other. And what about Java? So for example, we have this Java program building script right here. It is working with the Ant compiling, Java compiling tool. And what you can do is to do ant, and then so this one will just build up the Java program. And the next thing to do is to run your program. So as you can see, every time when you run this program, it will just communicate with the Python version server-side program. And it's really amazing. Hello client Python. Yes, still the same thing. Okay, so this is the thrift RPC demo. Alright, so now we have finished the thrift RPC demo, and now let's take a look at the JSON RPC. So as you might just observed, the thrift, you still need to learn about its IDL, and actually it definitely has some learning curve, and it requires the transformation from IDL to the actual concrete protocol. And this protocol has to be implemented by different kind of languages. And thrift requires installing language-specific library on client and server machines. So for language-specific implementation of the T protocol and T transport. So which means definitely if you don't have this thrift library that is language specific on the client side or server side, you can basically you cannot use thrift for RPC communication. But for JSON RPC, it's a different story, and JSON RPC basically use JSON as the IDL data format, since JSON is prevalently used and there's no need to transform any other kind of IDL into any protocol because JSON is the protocol. And interpretability is like different language specific implementation follow the same protocol written in JSON, and parsing JSON can be done by almost any programming language nowadays. Also, for JSON RPC, it uses the HTTP for transferring the message and data. So the transport layer is well addressed by the existing HTTP-based communication mechanism, and this is widely available in different programming languages. But for the performance of JSON RPC, it may not be as good as Thrift because the overhead of the HTTP protocol and also the JSON data format itself, because it's totally not a condensed one. It's basically a textual representation with a lot of labels and symbols. In our project page, if you go to the JSON RPC demo right here, this is basically a demo of the JSON RPC server-side program. And you can basically see through this example. But here I'm just going to guide you through the code. Since this program is written in Java and it's basically combining the Spring Boot technology along with the JSON RPC, so you basically need to learn a little bit about the Spring Boot framework, including the Spring itself, and also you need to learn about the JSON RPC 4J framework as well. And so at the server side, basically we define this interface right here that is a calculator interface. So it'll just be exposed at this URI. And for this function, it actually accepts two different parameters. And for JSON RPC, we just indicate them as A and B. And also at the server side, we provide the implementation for the interface. So this is the implementation actually, and as you can see, it is exposed as a service in the Spring framework. And this one is like the actual implementation of the interface. And this is the JSON RPC client-side demo. And for this one, it is basically a client-side program. And here we also have this interface already defined. And as you can see, both the server side and also the client side have the same interface definition. But the implementation is a little bit different. So as you can see here, this is the actual implementation, which is basically to call up the client-side instance of this method. And here we also have this Spring Boot configuration file that actually, configures the HTTP client. So as you can see, the base URL is something that we defined, and it is defined in the resource file, this property file right here. So this is the localhost A0A0. And as you can see here, the endpoint is actually this endpoint, right? So this is the JSON RPC HTTP client. And this bean is basically a proxy that is generated by the Spring Bean Bean Factory. And it'll just take this JSON RPC HTTP client as a very useful component for invoking, sending the request to the server side. And also for testing this client-side program, we also implement a RESTful service. So the RESTful service is also very interesting to know. And here we basically expose this method as a URI. So it's like a hierarchical URI. And as you can see, the actual, we don't have the concept of endpoint right here, but we have this interface directly exposed as a HTTP based URI. And so all it does is to call up the service, which is basically the JSON RPC client-side method. And later on, this JSON RPC client-side program will just initiate another HTTP request to the server side, to the JSON RPC server-side program. So, okay, now let's run this program. So, what you need to do is basically to generate this project, compile and generate this project. And now you have this jar file right here. And to run this program, what you need to do is to basically, you can go to this page and there's a command for running this program. For example, let's see, you are running. This is the JSON RPC server-side program. And as you can see, it's now running. And so for JSON RPC, we can definitely communicate with the endport just with the regular HTTP client. So for example, the CURL program. CURL program is basically a HTTP supported testing tool that will send HTTP requests to any HTTP based address. So as you can see here, we can basically send a post HTTP post request with this JSON format message indicating the method that we're going to call and also the parameters we're going to pass. And the content type in the header that we specify as the JSON format. So as you can see, it will just give you the returning result, which is basically also a JSON format, and the result is 30. That is 5 times 6 equals to 30, right? And so what about the client side? So you can basically run this client side program. So for example, the client side, you can run it like this. Definitely, before going to the client-side program, what you need to do is also generate the executable jar file and go to this folder, and then, okay, now, as you can see, the base URL, we basically can pass this base URL for the JSON RPC as, let's say, the a parameter for indicating the global property. And since we just start this JSON RPC server at the port of 9090, so basically when we run this program locally, you can just like do localhost, and then we can expose the RESTful service at this port number. And now let's see. So now the JSON RPC client program already started, but since it only started the program, but it doesn't send any JSON RPC requests to the server, so there's nothing happens. But you can initialize a JSON RPC request by calling up this RESTful service. Let's see. So now, for example, if you do like local host, so basically it's calling up the RESTful service that is being deployed at the JSON RPC client, and then it'll just call the JSON RPC procedure at the client side to initialize a JSON RPC request to the JSON RPC server. And let's say, what if A equals to 5 and B equals to 6? So as you can see here, this is the result, 30. So now I'd like to give you guys a little bit more information about what's going on behind scenes in this JSON RPC demo. So definitely we have this JSON RPC client and also the RPC server. And on the JSON RPC client program, we also integrate a RESTful service that expose as a RESTful interface. And we use the CORL command line too to send out a HTTP post request to this RESTful service. So the RESTful service will call the RPC client to send out a RPC request against the RPC server. So the RPC server will calculate, will do the actual calculation and return the result back to the RPC client. And then finally, the result will be sent back to the CORL2 as a HTTP response. Now you have already know the example of the RPC and also the RESTful service. And for a RESTful service, actually, instead of the underlying protocol describing the procedure and function calls, the procedure exposed as a service or online resource by HTTP protocol. And also, only the actual data exchanged by the predefined format in, or let's say, JSON format or maybe XML format. So the extra information about the procedure is not really necessary in the message. So no extra information about the procedure is required. And the difference between RPC and RESTful is for the RPC, the client step and server step hides the complexity of marshalling and unmarshalling the messages. But for RESTful service, developers need to design the message that will be transferred between the client and server, and also they need to take care of the parsing of the message. And for RPC, the application layer communication protocol is managed by the IDL and also the client step and also the server step. But for the RESTful service, the API developer actually defines the service. And for RPC, actually, there's less flexibility to API changes. So once you change the actual API that will be exposed through the IDL, you always need to change the both the server-side program, also the client-side program. Especially you need to regenerate the client step and also the server step. But for RESTful service, it is more flexible to API changes. So the server can make its change without bothering the client, as long as the API parameters and data messages are compatible to the previous version. And RPC can work directly with TCP, that is the transport layer. But for RESTful, it will only work for the HTTP layer, that is basically a application layer protocol. And there are still a lot more differences between RPC and RESTful. So I highly motivate you guys to think about it, and you can give comments down below. Okay, thank you. So if you think this video helps you a lot in understanding RPC, or if you think this video does a really good job, you can subscribe, share, or if you have any questions, you can always leave comments. Bye bye.